Good morning. This is Unit 1, Day 6, Combination of Functions. This is probably my favorite part of this chapter. We're just going to talk really quick about f and g. They're two functions with overlapping domains. We're talking about the sum of these two functions, f plus g of x. This is the same as f of x plus g of x. It's pretty much the same for the rest, so I'm just going to go through it. The difference, f minus g of x, is f of x minus g of x. The product means multiply. We're going to have f times g of x. That's the same as just multiplying the functions f of x times g of x. Also, this is a dot times. The quotient means we're going to divide. So f of g, f divided by g of x is the same as f of x over g of x. Pretty straightforward, right? We have to put like a little disclaimer in here. As long as g of x doesn't equal 0. Remember, we can't have 0 in the denominator. Alrighty. In each case, the domain of the new function consists of all numbers that belong to both the domain of f and the domain of g. It says, defining new functions algebraically. Number 1, if we're going to let f of x be 7x minus 5 and let g of x be 3 minus 2x squared, what is f minus g of x? So I'm going to show you how to do this one. Remember, f minus g of x is the same as f of x minus g of x. Okay, there's nothing really too difficult about this. I'm going to write f of x first, which is 7x minus 5. And then I'm going to subtract, because we're talking about the difference. So minus, this time we have to use our parentheses. We're going to have to distribute. G of x is 3 minus 2x squared, okay? It's really important that I put the g of x in parentheses because I have a minus here. I need to distribute into the binomial. Okay, this is going to be 7x minus 5 minus 3, and then plus 2x squared. There's only one term with x squared, so that I'm going to put first, 2x squared, and then I have one term with x, which is 7x, and then I have two terms with numbers. I'm going to combine that and get negative 8, and that's it. It says evaluate f minus g at negative 4. So what I'm going to do is I'm going to use this. F minus g at 4 is 2, and then x squared plus 7x minus 8. And I'm just going to substitute in 4 for x. So 2, 4 squared plus 7 times 4 minus 8. 4 squared is 16 times 2 is 32. 7 times 4 is 28. Minus 8 is, this is 20. Plus 32 is 52. Check and make sure I'm right. Now, I'm going to go over this one with you. This one says, let f of x equal x cubed and g of x equal the square root of x plus 1. Find the following given the domain of each. So first we're just going to do the actual operation. F plus g, or f of x plus g of x, is x squared plus g of x is the square root of x plus 1. Now, there's nothing really I can do other than this. The domain is going to be restricted. This is not restricted. I can put in negative numbers into the x. I can plug in 0 squared 0. That's fine. This is going to be restricted. Remember, we can never have a negative underneath the square root. So I'm going to find out where this is negative. The square root of 0 is okay. The square root of 0 is 0. So where is x plus 1 equal to 0? We're going to find that out. When I move the 1 over, remember I have to subtract it to move it over. So x is equal to negative 1 when x is negative 1. That's the lowest I can get. I can't have negative 2. So I can include negative 1 because negative 1 plus 1 is 0. That's okay. But it has to be negative 1 or more. It can't be less. So this is going to be my domain. I want you guys to try this one. I'm going to help you with the multiplication. Remember, f was x cubed, and g was the square root of x plus 1. So again, the x cubed, it doesn't matter when we're multiplying, it doesn't matter. The x cubed can be, or x can be anything. However, the square root of x plus 1 is still going to be restricted. Remember, x has to be greater than or equal to 1. It can be equal to 1. That's not going to change in this case. Now for the denominator, this might be different. Remember, f was x cubed, but g is the square root of x plus 1. And in this case, we cannot have 0 in the denominator. So if this is negative 1 plus 1, that would give us 0. So 0 wouldn't work either. So it's still going to be negative 1 to infinity, but we can't include negative 1 this time. So these are both parentheses. Composition of functions, these are really awesome. Remember f of g, we substitute g in for f. Okay, so it's always the second one into the first one. I encourage you to pause the video and read this. So I'm going to go over a composition function with you. F of x is x squared plus 1, and g of x is 1 over x minus 3. H of x is the square root of x. And then say the domain for each function. So this one is asking us for f of g. So this is when we plug the g into the f. So f of g of x equals, I'm going to start with f, which is x squared plus 1. And instead of writing x squared, wherever I see an x, I'm going to substitute in the g. So this is 1 over x minus 3. And then I have to go back to the f squared plus 1. Now, remember your order of operations. We're going to square this. 1 squared is 1. X minus 3 squared, this is a binomial squared. This is the same as x minus 3 times x minus 3. Then the plus 1. I mean, we can really just leave it like this. I can't simplify it after I FOIL it. But just remember, you can FOIL. The domain restriction would be when x is positive 3. Because 3 minus 3 is 0, and we cannot have 0 in the denominator. So my domain restriction would be I can go from negative infinity to positive 3, okay? And union, I can start back up at 3 and then go to infinity. I want you guys to try this one. In this case, you're going to substitute f in for the g, for the x's and the g. I'll do the f of x, f of h with you. My function is x squared plus 1, and h is the square root of x. So remember, we're going to substitute this in for f. I'm going to do pretty much the same thing. It's x squared plus 1 is your f. And I'm just going to substitute in what h is, which is the square root of x. Now, what's really cool is the square root and squared are inverses of one another. They cancel each other. The square root of x squared, they cancel each other, and you just get x plus 1. And there is no domain restriction for x. You can plug in 0 or negative numbers, anything you would like, and you'll get a good number. So the domain is going to be, you can use negative infinity to infinity, or maybe all real numbers. I'm going to use this. Okay, so this next one is g of x. So we're substituting g into itself. And this one looks a little tricky, so let's try it. G of x is 1 over x minus 3. Just need to remember that. So 1 over x minus 3. This is g of x, okay? But where x was, I have to put in g of x again. So this is also 1 over and then x minus 3, okay? You cannot combine these. This is a fraction. We really don't even have to simplify it. I know that x cannot be 3 because 3 minus 3 is 0. What I'm just going to do is simplify this though, because there's like a fraction inside of a fraction. I know that's a little confusing. So what I'm going to do is multiply everything by this denominator. If I multiply the bottom, the whole thing, by x minus 3. Remember, I have to do every term. So this term and this term by x minus 3. I also have to do the top by x minus 3. Otherwise, I'm changing this equation. So this is going to be x minus 3 on top over, this is 1. X minus 3 divided by itself is always 1 minus, and then I'm going to distribute this 3, and it's negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And I'm just going to combine like terms on the bottom. X minus 3 is on top. And then I'm going to put 10, 9 plus 1, minus 3x. Okay. Alrighty, so let's look at this. The numerator, the domain is not going to be restricted by the numerator in a fraction. However, the denominator it will. I need to know where the denominator equals 0. I'm going to set it equal to 0 and find out where. I have to subtract 10. Negative 3x equals negative 10. Divide by negative 3, x equals 10 over 3. This is my domain restriction. Also, x cannot be 3. We knew that from this fraction. X cannot be 3. So those are my two domain restrictions. So I have negative infinity to 3, 3 to infinity, and then, or 3 to 10 over 3. It's bigger than 3, so I have to put that second. And then 10 over 3 to infinity. Alrighty, those are my two domain restrictions. I want you guys to try F. I'm going to keep going. Decomposition of functions. So the inside of this is x plus 3. The outside is this squared. You guys can try this. Let's try D. So this one is, the inside is x minus 2. Both of them have it. It's x minus 2. But the outside is x squared minus 4x plus 5. Right? That's the outside function. I want you guys to try B and C. This one asks you to write it two different ways. I'm going to try one way, and then I want you guys to try the other. I'm going to say that f of x could be the square root of x. Okay? So the square root of, and there was an x underneath here. But then g of x would have had to have been whatever's underneath. So 3x squared plus 1. Is there another way to have a composition function to look like this? Try it out. This one says analyzing combinations of functions. So if they're given a graph, can we find out what f plus g at 3 is? Well, this one is actually pretty easy. Remember that f plus g at 3 is the same as f at 3 plus g at 3. So f at 3, this is my function f of x, this is g of x. If I go over to 3 and I go up to the graph, it's right here at 2. So f at 3 is 2. Now, G, I also have to go over 3, and I go up to the graph, it's at 1. And it says 1 because we're going to add because it tells us to right here. So that is 3. Let's try 6C. So remember, F divided by G at 0 is the same as F at 0 over G at 0. F at 0, that just means I'm going to go over to my F function, go over, this is 0, I'm going to go up to the graph is 4. Now G, my G function, I'm going to go start at 0, go up to the graph, it's also 4. So 4 over 4 equals 1. Let's try composition. F of G at 4. So this one is a little tricky. This one is the same as F at G of 4. So this one we always go and we start from the middle and work our way out. So G at 4, I'm going to start with this. G at 4, that means I'm going to go to the G function. I'm going to go over to 4, and I see this is 0. My Y value is 0. So this means that I'm going to plug in 0 for the F function. So I'm going to go to the F function. I'm going to go start at 0, and I'm going to go up to my graph. We're at 4. So F at 0 is equal to 4. This is my answer. F of G at 4 equals 4. I want you guys to try the other ones. This is all that we're going to do today. Let me know if you guys have any questions.